Hi dear students, let's see this question that came in JEE Advanced Paper 2 Physics in the year 2020. This question was from the topic of electrostatics, and I'm sure that all of you would have seen this question while you were preparing for IIT. This is a very famous question, but because of one particular word mentioned in the option, this again became a highly ambiguous question and this was much talked about. But again, to the dismay of many students, many good students, let me tell you, IIT did not revoke their answer and they stuck to their original answer, which in my opinion is not correct. So let us see what is happening over here. Two spheres of same mass are suspended in air by a common point by two non-conducting massless string of same length. In equilibrium, this angle between the string is alpha. So now they are immersed in a liquid of density 800 and dielectric constant 21, and the angle remains the same. So we have to comment upon whether electric force has remained same, or between these spheres it has remained same or it has reduced. We have to compute the density of these spheres and we have to comment upon the tension, whether it remains the same or unchanged. So how do we do this? Again, see, if you see carefully, initial situation is this: when they are not dipped in any liquid. So this angle is alpha. So we can say that this angle will be alpha by 2, right? So if you see one of these spheres, so there are three forces acting on this: tension, gravity, and this will be electrostatic repulsion. If we apply Lami's theorem and balance the electrostatic force and gravity, so directly we can say that electrostatic force, which is kq square, where q is the charge on both these spheres, q and q. So kq square by r square, where r is this distance. So kq square by r square, this is the electrostatic force, divided by sine of this angle, which will be 180 minus alpha by 2, because if you see carefully, this angle will be alpha by 2, right? So this angle will be alpha by 2, right? So this angle will be 180 minus alpha by 2. So sine of 180 minus alpha by 2 anyway is alpha by 2. So electrostatic force divided by sine of this equals to mg upon sine of this. M ko we can write volume into density of this sphere, which is what we have to find, into g, mg upon this angle, right? So this is alpha by 2 and this is 90. So 90 plus alpha by 2 is sine of 90 plus alpha by 2 is cos of alpha by 2. So from here we get v rho sg is equals to this whole thing, or we don't even need to write this. Let's continue. Now, once they are dipped in the liquid of density 800 and dielectric constant 21, net force on these spheres, like net electrostatic force on this sphere, will reduce by the factor of 21. Net electrostatic force will reduce by the factor of 21. The angle has been given to be same. So we can say that kq square by r square was the original force. Let's reduce this by a factor of 21. Angles have not changed, so we can directly write this as sine alpha by 2. That will be equals to net mg effective. So we can say that mg will be acting in a downward direction and Buoyant's force will come into picture in the upward direction. So this is mg minus Buoyant's force, which is v into density of liquid, which is 800, into gravity divided by cos of alpha by 2. Now you can see that if you take 21 this side and cos alpha by 2 this side, so we can just bring cos alpha by 2 this side. So this expression, we can equate the value of this expression. Like if you bring cos alpha by 2 this side, so whatever we will get here, so that is v rho sg. That will be equals to, if you bring cos alpha by 2 this side and 21 on the right side, so we will be left with 21 into v g common rho s minus 800. Right, Vg will be gone, so this will become rho s equals to 21 rho s minus 21 into 800. So this will become 20 rho s is equals to 21 into 800, so which gives us 840. So density of these spheres is 840 kg per meter cube, which is easy to find, and hence option C is correct. tension in the strings holding the spheres remains unchanged. This will be wrong, because it is easy to see that initially the tension cos alpha by 2 will be mg, and finally tension cos alpha by 2 will be effective of mg and buoyance. So mg and buoyance, like because of the involvement of the buoyance force, tension will have to change its value. So it will not remain same, it will change. So these two options were quite easy. Now the option A and B is what created the dilemma. IIT had given option B correct. So according to IIT, these two were the correct options. They have said that electric force between these spheres will reduce. But I'm sure that all of you know this, that electric force between the sphere does not reduce. Net force on these spheres will reduce. Because of the polarization of the medium also starts applying the force on the sphere in the opposite direction because of the polarized fields. Hence, the net force on the sphere reduces. But if you talk about the force between these spheres itself, then that force remains constant. So since the option is clearly saying electric force between these spheres, hence it would have remained unchanged. So according to me, option A was a better option. If this question comes in Olympiad or any other international level exam, then most certainly option A will be taken as the correct answer. Now, one argument can be given in the favor of IIT, that they go by what is prescribed in the NCERT. And in NCERT, it is mentioned that the electric force between these spheres will reduce, because I think NCERT believes that electric force between these spheres is the net force. But in my opinion, this is not right. So according to me, whenever there is a clash in what is correct and what is given in NCERT, I think it should not, such type of things should not be asked. So my take is, had I been the student, I would not have marked option, I would have marked option A, or better, I would have left it out. If I was aware of the fact that in NCERT what is given, then I would have left it out in order to avoid negative. That is my take. I hope you would have enjoyed this solution. Thank you.